You give me the go. Hello, everybody. My name is Sorce, and I'm going to present you something about Federation. I've been working on identity management project for a while at Red Hat, and we decided to look at this thing. And the idea I had for this talk is to provide a little bit of a primer of what Federation is, and finally present a little bit of this new project we built called Ipsilon. So what is Federation? Very simply, it's about dealing with users that you don't have any control on, that you don't own, that you don't manage. But you still need to let into whatever application you have. And to do that, you need to basically trust some third party. You need to trust something else to tell you who the user is and whether the user is authenticated or not. So for example, you may have two organizations, and one organization owns an identity. That organization may be the company you work for, or maybe a department within a company. And you need to access services that are provided somewhere else. It might be a different company. It might be an internal department in the company that is foreign to you. And you have a few constraints, or you would like to have them when you do that. You don't want the user to have to create new user accounts every time a new service is offered by a third party, because that's really annoying. The user gets confused. He doesn't know what credentials to use. You might not want the third party to have full view on your identities. Maybe you just have a small group in your company or your organization that accesses these services. Why that organization needs to know everything about your users? So you need to trust this third party, but you just don't want to have to let this third party do everything or see everything. So how do you do that? Of course, once you start giving out to third parties, then you might need to trust the third party, because now you have something going on in this service and something going on in the other service, and your user tells you, well, you know, well, I have some data here and some data here, and I need to put this stuff together. So how that work? And so when you get in that situation, you have a real federation in the end, and you need to do things like delegation, which means allowing the third party to talk to another third party on your behalf. And how do you do that? How do you allow this one of them to access only a subset of your data in another service. You want your own organization in control of what kind of data can be exchanged by these two third-party services. And you need to make it simple for the user to be able to give access to one of the other, to its own data. And let's define what is not federation. Because this is something that has been done a lot, especially in the open web. Giving your credentials to someone is not federation. So if you have a service that asks for your username and your password on a third party, that is not federation. That is just surrendering control. That is just, someone stealing your credentials. You don't have any control on what that party is going to do with your credentials. You have just a promise that he's going to be nice and not touch your other data, or not lose your password and not store it in plain text somewhere. You basically have to just trust them, but fully, and that's not what you want. And from the point of view of this third party, it might be the only option they have in some cases, or have had, but they don't really want to do that because it's a liability. What if they screw up and now you're angry with them? And there's also the problem that you don't really have single sign-on because you're transferring your password. You run into a number of issues like, oh, I changed my password now, and that service doesn't know my new password, and it's failing to do the stuff that it should do. Very unfriendly environment. Okay, so how do we solve this problem without giving credential out? How do we solve the federation problem? So there are a number of protocols that have been invented, mostly in the web/HTTP world, because that's where this problem was first felt really heavily. Most of these federation protocols may depend on authentication flows that requires interactivity, meaning a browser and a user actually behind the browser. But some of them has been modified or from the start built to allow also non-interactive use, which is important for automation. They might still have some interactivity needed to set up the whole thing, like when you set up delegation, you may have the user have to actually provide some information to you, what you want to allow, but then they try to work without any additional interaction. And there are a few protocols that are well known. This is a list of them. SAML, OpenID Connect, Persona maybe not as well known. And there will be more, and there have been others. These are the ones I care about a little bit more. And they're interesting because either they're used a lot or because they have workflows that are different from one another. There are differences in what they can provide. And so we'll see how this works from the point of view of the flow of information. Very high level, not going into the details of the protocols, but I will point out what are the key differences. So a little bit of glossary. There are two terms that are really important to understand if you want to follow what's going on here. One is the term identity provider. This is a server generally that you have, most probably in-house because you own the identities, and it authenticates the users for third parties. So it's called usually identity provider, I think, in all of these protocols. And then there is the service provider or relaying party term. This is just different name, different protocol with different name, but it's the same thing. It is basically a component of the third party that talks to the identity provider. And then usually it's also the service that the user is trying to access, but it might not be. It might just be some proxy that the third party provider uses and then manages its own sessions and stuff, but it is a fundamental component to allow federation to happen. So these are the two things that you care about. So let's see, as an example, one of the protocols. So SAML, of course, the S, as in most security stuff, is for simple, and ML for middle language, but it's not simple at all, but whatever. So it's interesting because it's one of the few protocols that actually requires an agreement between the parties before anything can be done. And by agreement, I mean an exchange of information. In this case, the most important part is public keys. It is based on public crypto. Other important thing is it tries to keep control very much into the entity provider. The entity provider decide what data can be released about users. And it also allows one thing that the others don't, which is encryption of the data before transmitting it to the third party. It is very single sign-on friendly. Not only you can have single sign-on from your own identity management system, whatever it is, to the identity provider, but then it keeps going on to the relying party. And has another feature that is very enterprise friendly, which is the single logout feature, which allows you as an administrator or as just a user to basically log out yourself from any third party. This is very, some people like that when they think about termination. And therefore, it is very, very enterprise oriented. It is based on interesting things like XML, SOAP, especially XML sec, signing of XML, things you don't want to think about, and that's why we want to put them into something that you use, but you don't look under the hood. The spec is managed by Oasis. Let's see what's cool about it, at least from the higher level. So this is what an authentication transaction kind of looks like, very, very, high level. You have a user that needs to access some service here on the left. It doesn't matter what it needs to do. When the user first tries to access the service will check whether the user has some session with it, whether it has already been authenticated or not. If not, in most cases, it will be sort of redirected back to the identity provider, the server that has the user credential or knows how to access user credential. Some magic happens there. A bit of data gets created, signed, and sent back to the user browser that sends it back again to this new service. And after this, the user is authenticated to the third party and can go on. So what is the key point here? If you look at it, you will see there are no arrows between the server, the service, and the identity provider. They don't talk directly to each other. Everything goes to the user browser or agent, whatever it is. And this is possible because of the first exchange we made, the first agreement where public keys were exchanged. There is indirect communication between the two because there are messages going on through the user browser, but no direct one. And this is really useful because then you can put this identity provider within the premises in the company and not have it exposed to the outside. Only the user can access the internal identity provider. And still, the user can access external resources and have this magic happen. So the user becomes the gateway between the two sources, the internal closed network and an external open network. Once this is done, usually the user just talks with the third-party service and keep doing whatever it needs to do, and doesn't interact anymore with the identity provider. OpenID Connect. This is a very interesting protocol. It's taking some time to make it, but it is being adopted by many very well-known providers like Google and others like that. It is very user-driven. The user might decide to tell a third party who is the ADP. There is no pre-agreement needed between the third party and the identity provider. The user might also be usually allowed to decide what kind of data get released to the third party. It's not the admin of the identity provider that decide up front necessarily, but the user might decide what kind of data get transmitted. By the way, OpenID Connect is not OpenID 1.0, not the other stuff you might be used to if you know Fedora. And it uses more modern things like REST, JSON. And it is based on OAuth 2.0, which is this huge, strange spec that was built mostly for the delegation problem I mentioned earlier, and has been basically adopted and changed so it can be used also for authentication with the OpenID Connect specification. And OpenID Connect also restricts the very open-ended OAuth 2.0 spec so it can be used interoperably in an interoperable way between multiple providers. So let's see the flow, which you can see is different from the previous one. So the user interaction, similar. You go to the service, you're not yet authenticated, you go back, go to the IDP, authenticate, you get something, you hand to the service. However, because there is no pre-exchange of public certificates or anything, now your service doesn't really know that you are who you say you are. You could be sending garbage. How does it know that you are authenticated? It doesn't have a cryptographic mean of checking that your assertion that you are who you are is really true, because there is no signing from a trusted party, like in the previous case. So what happens is that in OpenID Connect, there must be access from the third party to the identity provider to verify that the bit of information the user gives back as part of the authentication process is really valid. And so the consequence of this is that you have to open the IDP to the external world. But the very good thing is that you don't need pre-existing agreements. The user can go to the third party and say, hey, you know, my identity is there. So if you want to trust whatever that thing tells you, you can just go there at any time. This is a token, go there and see what it tells you. In this protocol, the third party is called reliant party, not service provider, but the same thing. So, other protocol, they all solve the same problem. They just work slightly different ways. Persona is just the commercial name, but it's the name that is most well known. The real protocol name is called Browser ID. It is a spec that has been pushed a little bit by Mozilla. It is very privacy-oriented, and why I pointed out is that in the previous two protocols, as you see, in one, you have to have an agreement between the identity provider and the third party. And every time you authenticate, there is basically a communication going to the user browser. So the identity provider knows all the time who you're talking to. Same with OpenID Connect. It knows who you're talking to, and the service provider connects and talks to the identity provider. And that means that the identity provider knows every single time you authenticate who you're talking to, what kind of service you're accessing, and who you are. And Mozilla didn't like this because they wanted to target this protocol to identity providers that are public companies, for example, like I guess they wanted to have it Google or Facebook use this. And they didn't like the fact that this company could follow every move of the users. They wanted to allow the user to have the ability to use a service they know and the service that is known to the world, can be trusted, and where they have an identity, but they didn't want to allow these services to know every single user move. So they tried to build a protocol that will allow you to still retain the authentication part without the revealing of your traces part. It is currently usable, although in their plans a browser plugin would have been the best way to do it, but they just provided very heavy JavaScript instead that you can use these days. And they have the constraint that it has to be based on an email address for your identity. You can't just have a username somewhere. It has to be an email address, it has to be public, there needs to be a website that hosts the IDP public certificate, and it uses crypto to do its magic. So how does it work? As you can see, this is a little bit different on the user side. there are some lines, and I'm going to explain what they do. The user has to contact the IDP to do the authentication, of course, at some point. But the nice part of Persona is that it does authentication, and then it receives a little bit of magic called short-term user certificate. The only important part is that it is short-lived. You will get it in the morning, and maybe it expires in the evening, and you get another one the next day. But you get it only once in a while. You don't have to keep going there. And so when the user needs to access the external service, they'll go to the service, do some magic locally, use this loop locally, and then send back something to this service. Now, how does that service know that what you send is true again? In OpenID Connect, we saw that it has to go to the identity provider to validate whatever the user told them. In the case of Persona, that doesn't happen. Due to magic crypto stuff, the only thing that the service provider needs is to download once in a while the public certificate of the IDP, and it can do the validation locally. What that means is that the IDP doesn't know where the user goes, ever, because the user doesn't tell the IDP why it wanted its own small user cert when it contacted the IDP, and the IDP doesn't know where the user went. It just knows that some service providers ask for the public certificate, yes, but it doesn't know which user went where, when, because this public certificate will be cached by the service provider and can be used over and over and over again for ages. So they actually accomplished their goal of not allowing someone to track you, and the protocol works and it's nice. They lose something. There isn't the ability for the organization that has the identities to revoke them immediately. So if you lose your password and use this protocol, you will be exposed for an amount of time, because there is no communication between the services and the identity provider. There is no way to revoke your access until the nice certificate you had expires. So trade-off. Okay. I'm not going to the details of the OpenID protocol because it's similar to the others and didn't have any real difference I wanted to point out. So I'm going to talk about the Ipsilon project instead, which is a project I started a year ago, and that changed to start. So let's see what is the goal of this project. Of course, is to be a pluggable identity provider, meaning it implements the part that allow you to expose your identities to third parties. Pluggable because we want to make it possible to use whatever is available. Whatever is available both in terms of authentication for the user against your own identity store. Ipsilon is not an identity management server. You cannot create users in Ipsilon. You cannot set passwords in Ipsilon. You have to have your own store, whether that is free APA, whether that's an Active Directory, an LDAP server, a password file somewhere. Not my business. I don't care. So we need to support multiple authentication methods and multiple ways to retrieve methods to retrieve information from whatever service is available. Another part of the pluggable part is that we don't care which federation protocol you like. You like SAML? Cool. You like OpenID Connect? Cool. You like them all? Fine. And the reason is that you don't control what third parties actually do support. You may want to talk to two of them, and one support one protocol and the other support the other protocol, and if you try to fixate on one, it won't work. And so we wanted to be able to support multiple protocols. And because of the complexity of the whole thing, we want to make it easy to use. We want to allow you to just run a script and it's done. Not have to think how the protocol works, how the crypto is. It needs to just work and hopefully work well and securely. So we've been concentrating on trying to build an installation script, so you just run a command and it's installed. Have a decent configuration management UI, have tools to allow you to configure your own third-party services if you're on the other side. So it is built in Python, best run in MudWhiskey under Apache, but it also has a standalone mode if you just want to do some quick development. And the important part for us is that plugins are dropping. You just install whatever third-party plugin it will ever be, and it just show up automatically into the administration UI, and you can start using it. No grand configuration file to go and mess with. On the client side, we are still working on it. The most developed part is the SAML service provider. We use an existing external project called mod.melon that implements it, and we have in the installer ability to easily configure an Apache instance to use it with a single command. So, what's interesting about this project is that after I started and looking around, I discovered, oh, well, Fedora Infrastructure is actually using OpenID. What are they using for this thing? And so, through various ways, I got in contact with Patrick, who's here. He had built something very similar to Ipsilon. There were some differences in some of the flexibility and way we were building this stuff, but more or less same language, both Python-based, same long-term goals, multi-protocol support. And so we say, well, why don't we stop wasting time and building two things and try to just share what we do? And that's what we did. It was really nice that FedOauth started with OpenID while I was starting with SAML, because we could just have double the features in very short time. We also got Persona from FedOauth, and so we actually ended merging the two projects pretty quickly. It was a few months, basically, and we declared the merge finished in December 2014, and we hope that you will start using Ipsilon without knowing it soon in Fedora. If we do it right, it will just at some point switch, and you just keep going and use your Fedora infrastructure, and you will not know that you move from one to the other. So what do we support right now or in the short-term future? So we have modules for authentication. We support Apache modules. So if you already have something that uses Apache modules for authentication, even just down from basic auth to any fancy things, mod-out just API, mod-out curve, whatever, we support it in there. We support also form-based authentication, whereby we take your credentials and go to some store, like an app store. We can do Kerberos if you use that. And that means that we can also talk with things like FreeIPA, AD, whatever you like. And it's grayed out because we don't have explicit support of it, but it happens via Apache module, chaining to other IDPs. It's nice that you can actually have chaining to another IDP, because some people may have one in their company, but it may be restricted policies, or maybe it doesn't support all the protocols. You may want to chain Ipsilon to it. And by that way, you can actually use other federation protocols that way. Supporting info is a little bit less developed yet. Mostly we support LDAP. The rest is just for fun. We don't support getting the info from the other IDP, and that's why it is grayed out. It's kind of half done. But the idea is that if you do the chaining to another IDP, basically you will get the information from there, filter it a little bit, and you can send just a subset to a third party. And initially probably only under admin control, but potentially under the user control as well at some point. Protocol support. SAML was the first one I started with in the Ipsilon project. It uses, it has very few dependencies on the system, two C libraries that implement the XML part and the actual SAML part. It is implementing only the interactive features so far, and Not all of them. We are working on the non-interactive part of the protocol to allow machine-to-machine communication more easily. Of course, not all the features are there because the SAML specification is really complex. There's a lot of corner cases, but we do support whatever is needed for for day-to-day stuff. We actually use the client side of the release within Red Hat, for example, experimentally in some parts, and it works just fine. And I think it's pretty usable right now. OpenID is probably the more mature one, mostly because it was ported from FedOauth and it's been tested in Fedora Infrastructure. It's used every day. So we're pretty confident that one works well. It's also the simplest one, if you want, from the point of view of the protocol. We have persona support, although I haven't tried it. Patrick knows if it works or not. And we don't have OpenID Connect yet. So that's it. I'll try to do a little demo so you can see what I mean with all this stuff. Nothing fancy, just to see how it works. So, okay, that's my pointer. Okay, this is Ipsilon running in devel mode. It's very simple. If you do a git clone, you can run this command, and it will just start a basic Ipsilon server. It will use a fake authentication module just for testing, and it will not configure all of the providers, but it works for the OpenID case, for example, out of the box basically. And this is a simple service provider. I'm using just the example of the Flask OpenID project. You just git clone again and just run python example.py. So it's very easy to see how it works. These two, of course, don't have any UI, but I want to show this one. This is the simple UI you get from the Flask. So this is the so-called service provider. And in the OpenID case, OpenID doesn't require pre-agreement between the identity provider and service provider. So what OpenID does is ask the user the first time, so what is your identity? Where do I go? And it does it simply by pasting in a URL in the OpenID case. You tell it, you know, when you want to authenticate me, go to this place and sign me in. So let's see what happens, if it works. So, okay, now I have been redirected to Ipsilon because I was not authenticated in that place. And this is the UI we have. You can see on the right that disable this intro, don't use it, really. You can provide any username you like in this module, this authentication module, as long as the password is Ipsilon. And I will use the admin one, so I can show you a little bit of UI maybe, but you can really use anything. Let's see if I type my Ipsilon password right. Okay. It's done. So Ipsilon decided that my password was good and sent me back because its job is done. So you've seen Ipsilon. Okay, I can go. There isn't much to see, but the cool thing is it just works, and that's when security really is working. When you don't see anything and it works, it's okay. Now I could go on and create an actual account in that place. That's what most service providers will do when this kind of transaction is in place, is that they will create some cache with the username or whatever, so they can attach their own data there. But it's not really important for us. Yeah, I could create a profile, but it doesn't matter. So back to Ipsilon a little bit, though. So I logged in as an admin. And this is what you get if you are an admin and you get into the administration interface. You have only 3 things you care about. The identity providers, there are the 3 ones we support, and the login plugin. which are the plugins you use to actually access something. And so there is one I enabled before, I enable again. It's called FAS, which will allow you to actually use the Fedora authentication services for your authentication. So your Fedora login, your Fedora email and password. So if you enable that, and if your identity provider based on OpenID is enabled, which it is, you can do things like configure filters so that you allow only specific things. Like I could put a filter in here that says allow only the Fedora IDP, the Fedora infrastructure to work. Then by just enabling these things and going out, you can decide to try to log in with Fedora infrastructure accounts. So this one doesn't have the big warning, don't use it in production, because this is the fast login provider. You just put in your fast login. Yeah, it's okay. Wait. I have, this is my real password, so hopefully I get it right. Right, I did it. Yeah, I probably don't have network on this laptop. Yeah, whatever. You trust me, right? There isn't much to see. Just that it will talk to Fedora fast and then send me back to the other application. We'll be done. So that's about it. There isn't much to see, but that's what we like. If it doesn't much to see, it means it works. In this case, it doesn't. But. Okay, final words. A roadmap, where we want to go with this thing. One thing we would like to go, mostly because I work in that project and we like it in Red Hat, I would like to make it very simple, that simple to integrate with FreeIPA, so that you install it, and if your machine is in the FreeIPA domain, it won't ask you anything. It will just be working there. We're building a REST API for all the admin management part. The UI I showed you with the stuff you could select, at the moment is the only thing you can use. In Fedora Infrastructure, we have a special module, so we actually will put the configuration into a read-only configuration file, but that's not really friendly for automation. So REST API. And to simplify registration for the SAML protocol. So as I said, the SAML one has the trust has to exchange that has some additional setup that is not as easy as the OpenIDP one, and we want to make it much simpler to avoid having people getting crazy with exchanging all this data. So on Pro SAML, start with OpenID Connect. I think that's a very cool protocol and it's used widely outside, so maybe you should provide it. More authentication info plugins and perhaps some crazy stuff that is technically maybe not federation, but it's really useful within the enterprise when you use Kerberos and X509 certificates. So basically more authentication translation things that are kind of sort of federation but not traditional. That's it. Any question? Welcome. Yes. Yeah. A few minutes still?
4 or 5 minutes.
Okay. Okay, no questions?
What about SOA? Was it for SOA?
Yep.
Is it adopted?
It is in the project. The code works. The reason why we're not putting a lot of accent on it, there are two. One, it's a little bit difficult to develop on it because it requires kind of public services by default and all this JavaScript stuff. And their reference implementation is also built in Node.js and things like that. The other one is that it seems like Mozilla is not pushing it that much anymore. So we have it if people will like it, we'll keep going on. But I think the focus for us is SAML for the enterprise-y cases, because it seems like those kind of providers like it very much. And OpenID Connect probably as a replacement of OpenID at some point for the more consumer-driven cases. Like, I want to let Facebook handle my information or something, things like that. So those are the two protocols I think will go forward the most. They have the most adoption. The other ones, we just provide them, they support it, but we'll see how much they will be used. So we will focus putting additional features on the protocols that are mainstream, and then the others one we'll see.
So, silly question, who is your competition in this space?
Who is my competition? Pretty much there are tons and tons of people that provide identity providers, both open source and not. In Red Hat, there is another project called Keycloak that wants to do something like this. Every single one has a slightly different take. Yes, Shibboleth is one of them, but Shibboleth is really SAML-centric. I think the thing that sort of distinguishes us is that we want to be multi-protocol, multi-federation. We don't want to stick to one only. And the other part that most of the others tend to overdo, in my opinion, is that they try to actually do identity management. They actually create the users on the IDP and stuff like that. I don't want to do that. I think there are solutions for that already done, like free APA, LDAP, Active Directory. Why should I care about doing that part? I mean, that part is done, I just bridge to it. So I think those are the two key points that make Ipsilon maybe more interesting. Yeah, the third one, oriented to administrator. Yes, that's it. Making it simpler. And I think we are out of time. If you have more questions, I will be out here. Thank you. I forgot to turn on the network. I forgot to turn on the network. This thing works. It's my fault. I should have tried it in the first 5 minutes. You did it. Perfect. The demo part was the last. Something goes wrong. I could skip it.
It's always better.
Yeah. Never trust the demos.
Yeah. Není to udělané tím, že tady máme zapnutý pořád tenhle mikrofon, protože ho Juříček ráno zapl a říkal, že ho máme nechat zapnutý. To ho nikdo nechce, nikdo ho nepoužívá.
To je možná.
Ale jako otázka, jestli nám to nedělá tenhle.
Jestli to nedělá ten mikrofon, tak zapnutý.
Já nevím, já mám jako...
No, ono, pokud trošku víc vrčí to a necháme ho položený na stole.
To je dost možné.
Může vrčit.
Tak můžeme vypnout, protože ho stejně nikdo zatím nechtěl. Asi.
Tady tím červeným těplíkem.